Welcome to this presentation of threads and tying it all together in the Introduction to Programming class for non-programmers. My name is Donna Martin, and I will be your instructor. If at any point you want to ask a question, just use the question comment box. Let's get started. So in this particular section, we're going to revisit our ballerina script because we want to talk about threads, and I'm going to explain what those are by just giving you the example. What we have with the ballerina script is we have a script that is running, and if I was to go out and bring in another script, for instance, let's bring back our gravity sprite that we had before. And so now I have the gravity sprite and the ballerina on the screen. These sprites run independently of each other. The gravity cat actually has two scripts associated with it, but the gravity cat scripts run totally independently of the ballerina scripts. They both start on a green flag. So let's go ahead and start both scripts. The gravity cat is going around doing his thing. Let me get a larger screen here. So here we have the gravity cat going. He isn't at all paying any attention to the ballerina. The ballerina wants to know how many times to jump. Let's tell her 12, just so we have time. She's going to be jumping away and executing her script with no idea what the gravity cat is doing. These are called threads when you have two separate processes that are running, and quite a few languages support the idea of threads, though not usually in quite as straightforward and simple a manner as this particular language does. So our ballerina is doing her 10th, her 11th, her 12th jump is coming up, and she's done. The gravity cat is still going because he has no interaction with the ballerina, doesn't care whether she's completed or not. The only way to stop him right now is to click on the stop sign. So these are two separate script sets that are running independently of each other. However, in Scratch, you can actually communicate back and forth between different threads. So let's see how we go about doing that. Let me stop everybody. Let's go back and let's look at, for instance, the gravity cat. Remember, its first script just sets up where he is on the screen. The second script just starts him bouncing around doing his little drawing. Well, let's go look at our control palette. And in the control palette in the middle, you will see that we have three blocks that are of interest to us now when we deal with threads. There's a broadcast and wait, and a when I receive. Now, there's nothing in these little blocks yet, but basically what we can do when we have two processes that are running is we can broadcast a message between the two processes. The ballerina can broadcast a message. The cat could broadcast a message. You can have a totally different process that broadcasts messages, and those messages go out to the independent threads that are running. And then they can do something whenever they receive those messages. Now, for instance, if you just do a broadcast and you give it some sort of message, then as soon as you do the broadcast, your script is going to continue on. So maybe you're the controlling script and you just say, hey, everybody stop, or everybody reset, or everybody move 10 steps, or whatever. And then you continue on with whatever you're doing, so that you wait until the event happens and is received by the other scripts. There is also a broadcast and wait. The way a broadcast some message and wait works is that you send the message out to everybody, and then you wait until the other scripts have completed before you continue on. This is very helpful if you need to synchronize events between things. What I'll notice is a lot of times when people are doing Scratch applications and they want to do a story, a lot of times they'll have multiple sprites in their story, and the way that they'll implement a dialogue is they'll do it by waiting. They wait so many seconds and you say something, and then you wait so many seconds and they say something, and so on. But you could actually, depending upon the other parameters in your script, do some broadcasting so that you're more tied to a specific thing happening than you are waiting a certain amount of time. Now, if you are the receiving script, which is actually what we're going to have the gravity cat do, when you receive a specific event, you're going to do something, and we'll put block under here depending on what it is we need to do when we receive the particular broadcast. But let's start. We need to be able to, we're going to go back to our ballerina and we're going to have her tell us when she's done so that the cat doesn't keep running around. We'll have him stop when she stops. So to do that, we're going to have her broadcast a message after she's done with however many jumping jacks we tell her to do. We don't have any messages yet, so we need to create a new one. Let's just have her say something like stop. Well, not say, but she's actually broadcasting this message. The name of our message is just stop. So as soon as she's done and she returns back into her ballerina A position, she's going to broadcast a message to all other scripts that they should stop. Now, right now, the Gravity Cat doesn't have any information about that broadcast message. There's nothing in here that tells him to stop. So we're going to add that script for him. Again, let's go down to our broadcast section. When this Gravity Cat receives a stop message, and the reason stop is here is the only message that we have. If we have multiple messages, we would be able to select among them here. And let's say that whenever the Gravity Cat receives the stop message, let's just have him quit. Oh, actually, we don't want to just stop this script. We want to stop these scripts as well. So let's try this and see what happens. Let me go ahead and go back to our clear so that we can make things look a little bit better. All right, so let's start our scripts running again. She's going to ask how many times she should jump. Oh, I'm sorry, let me bring this up larger. How many times should I jump? The cat is running around doing his little gravity thing and drawing as he goes. Let's have her jump 8 times. Everybody's still running. She's jumping. He's drawing. They're totally independent of each other. There's not anything happening there. Everything's going fine. She's up to 5, 6. He's still moving around. 7, 8. She quit and so did he because of that broadcast message. So you can use threads to communicate back and forth between your totally independent items on the screen. So here is your workshop. There is a sprite called the Walking Dude sprite in the people category of sprites in Scratch. I want you to go ahead and load up the Walking Dude, and I want you to use our ballerina script from before, and I want you to be able to control them so that they begin at the same time. When the ballerina is done, I want the Walking Dude to stop also. So they should start and stop at the same time, and you're going to be doing that with broadcast messages. Now, you could just have them start at the same time with the green flag, because when you press the green flag, everybody starts. But I actually want you to have a third sprite here who is in control of starting the ballerina and the Walking Dude, so that they will begin at the same time and then they will stop at the same time because the ballerina communicates. So give that a try and then come back and look at my sample solution. So here we have our 3 sprites that I'm going to be using in my sample solution. I'm still going to use the cat as being in charge of everybody. I have my ballerina that we had before, and I have the Walking Dude, which we got from the people section of the sprites down here under Walking Dude, and he has a script associated with him. So that's how I loaded the Walking Dude. Now, I made some changes to him. So let's start by looking at the Walking Dude. Let me go to a smaller stage so we can see the scripts better. Originally, when I had the Walking Dude, he had a when clicked flag on him, so that when you did the click, he would just walk forever, doing all these things and turning around on the edge. I replaced that particular hat module, that particular hat, with a broadcast. When I receive a start message, then I have him start walking. If we look at the ballerina, I did the similar thing. Previously, we had a when the green flag is clicked as the hat starting the top of our script. I changed that to when I receive a start message. And just as before, I created a start message by going down into the broadcast area, the broadcast block, clicking on New, and I created a start. We had the stop from before. Okay, so if we go to my cat, he's the person that I put in charge. When the green flag is clicked, I have him saying, in 5 seconds, jumping and walking begins. And then we're going to wait 5 seconds, and then he will broadcast a start message, which the other people, the ballerina and the walking dude, should receive, and they start up. So that should get everybody going together, the cat being in charge and telling the ballerina and the walking dude to get moving. Then I also wanted to add a script to the walking dude. When the ballerina finishes, she is going, well, let's go to the ballerina. When the ballerina finishes, she does all her stuff. She does her jumping. She changes her costumes and does the jumping. Goes back to standing position. She broadcasts that she has indeed stopped. So the only person who's really interested in that is the walking dude, because the cat hasn't been doing anything this whole time after getting everybody to start. So if we go back to the walking dude, we added a script here. When he receives a stop message, go ahead and stop all of his scripts. So let's go ahead and start it off with the green flag. The cat says, in 5 seconds, jumping and walking begins. She asks, how many times should I jump? The walking guy starts moving his way across the screen right in front of her, and then he's going to turn around and go the other way. Let's have her jump 5 times. He's still walking. She is doing her jumping. And then once she reaches 5, she'll issue her stop message, and he will stop walking. Looks like right in front of her. Okay, so that's what happened. The ballerina reached the end of her script. She broadcast a stop, and as we saw before, the walking guy receives the stop, and he stops walking. So that's an example of using threads inside Scratch and getting them to communicate to each other. Now, the other thing I wanted to talk about in this module of the Introduction to Programming for Non-Programmers class is kind of tying everything together. I want us to go back and look at the square root script that we did earlier, so that we can see what that would look like if it was a C program rather than a Scratch program. Now, I have a C programming environment installed on this same computer, so I'm going to bring that up, and we're going to look at the module that we wrote for Scratch, and we'll see how you would do that in C. So I had saved the square root script, so let me go up to my file. I'm going to open a new project. I'm not going to worry about saving this particular one, and I had a project I called square root. Let me make the stage smaller again so we can see the script that we had before. When we click on the green flag, say we're going to solve this particular equation, wait, ask for a value, and wait till they enter it. We're going to think, and then we're going to wait, and then we're going to calculate the answer. We're going to check to see if the value they want us to take the square root of is positive. If it is, we're fine, and we go ahead and print the message. So let's see what this would look like as a C program. Now, we're not going to have a character that thinks something. We're just going to be writing back and forth to the user. So I'm not going to have my think, for instance, and I'm not going to have my green flag. I'm just going to run a program. But let me show you how this would look in C. So here is my C programming editor. This is a file I created called squareroot.c. As we talked about before, C uses a series of libraries of functions or routines that other people have written, so we don't have to figure out how to print to the screen or how to ask for a number or how to take a square root. We just have to know how to call that standard function that's available to us. The first line refers to the standard input and output library. Anytime you're going to be doing reading or writing, you will need that particular library. Since I'm going to be doing a square root function, I also need the math library. And these include files include this information that those libraries need to be able to process your request. So we have those at the top of our C program. Then we have our main program. Our main program, as we mentioned before, starts with the word main. It has a parameter list in case we want to select things from the command line when you run the program, but we're not going to worry about that, so it's just empty right now. And it returns an integer. we always want to tell the operating system if we encountered an error while we were running. So we come in and we're going to have a variable just like we did in our Scratch environment, which I called A. It's a real number. In C, you have to tell it what type of variable it is. It won't automatically adjust. So since we're going to be taking the square root of a number, we're going to assume that they can enter any real number as opposed to an integer. So it's a floating point number. I'm going to ask the user for the information. I'm going to say, I'm going to solve this equation. Please enter the value of A. And then in C, in order to pick up information from the screen, you use a scanf. And this scanf is saying to go and pick up whatever the user types in. I'm expecting it to be a floating point number, and I want you to put the answer in variable A. Now, when you get into C programming, if you go that way, you'll find out there's all kinds of error checks that you should make, and you need to make sure that they really do enter a floating point number, not a character. But we're not going to worry about that for this simple little program. Then we check to make sure, just like we did in Scratch, that A is not negative. If A is negative, we're going to print an error message. Sorry, I can't take the square root of a negative number. Otherwise, we'll go ahead and take the square root of A and print that answer. Oops, sorry about that. We're going to take the square root of A and we'll print it as a number with a floating point number. Means that there are decimal points. And then we're done. So let's see how this actually runs compared to Scratch. I'm going to bring up my C command line processor. Let me move this down. Remember I said that I had stored that in a file called square root C. And I think I told you that C is a language which has a compiler. So we can't just run it like we do with Scratch. I have to come into some sort of compiler and tell it to compile this code. So it does that, and it tells me I didn't have any errors. And then I have to create an executable, and it does that and tells me everything's fine. So I can now go out here and I can run my program. The name of my executable is by default with this particular compiler the name of my file, but it doesn't have any .c. Square root.c tells me that this is a C program. If I just use square root, or on a Windows system you can type square root.exe, that's the name of the executable. So now I run it. It says I'm going to solve x squared equals a. Please enter a. I'm going to use the same examples that we did during the class, 25, and it says the answer is 5. So let's try running it again, see what happens if I enter a negative number. Let's enter negative 100, and it says, sorry, I can't take the square root of a negative number. So we are actually doing the same thing in C that we did in Scratch when we had the square root problem here. Scratch was just a little bit more exciting because we had the cat talking to us. We said 25, and he said, that answer to that is 5. Let me run it again, but on the larger screen. We do the same thing we did for the C program, and we get 5. If we run it again, and we enter the negative 100, just like in the C program, we get, I can't take the square root of a negative number. So you are doing real programming, even though you have cute little cats running around and ballerinas jumping. I wanted you to see that this really is programming that you're doing in the Scratch environment. So I want to take a minute and just kind of remind you of the things that we learned in these particular modules, because I want you to really have a feel for the fact that you really have been doing some programming. We talked about the motions. Now, most of the motion type of blocks that we dealt with would be dealing with moving in a graphics programming language. We're not going to be moving objects around when we're dealing with C, though there are graphics libraries available to us that you can access through other programming languages that let you do this type of thing. In that case, you would be making calls to routines that somebody else wrote, and you would be including that similar to our standard ones. There is not a standard graphics library available, but there are several that are very widely used in different languages. When we did the looks, you did saying and thinking. That would be similar to output in a C program or in another programming language. So you've already dealt with outputting variables. You also dealt with input when we did the ask a question in the sensing area. when we asked what's your name and weight, and then it stored the value in answer. So you've done input and output. Now the sound things are really kind of particular to just having fun with Scratch, but it did give you some ideas of just solving problems and that type of thing. You can also do some things with the pen. We didn't deal a lot with the pen because we wanted to try to stay with more standard programming practices. But in the control area, you really are doing things very, very similar to the way that you would do things in other languages. It's just that the syntax is different, and we don't get to just drag blocks in when we're programming in other programming languages. But the fact that we have a when something happens, quite a few languages have this type of event type of processing. But most have loops, so this forever loop, this repeat loop, the if statements, the if else's, the repeat untils. There are similar constructs in other programming languages. So you're learning how to make decisions, you're learning how to do loops, and it just depends on what language you move into, what their particular statements look like and what their syntax looks like. We already said that we dealt with the ask. A lot of the things here, like the timer, the XY position, are particular to Scratch. Operators is also something that you're going to have in programming languages. You're going to be able to do your basic arithmetic, your basic comparisons. These things deal with strings. Here's a modulus, which is like a remainder function, the rounding, and then all of your particular types of trigonometric functions that you can do, which in C would be available in the math library. And then again, we talked about variables. When you make a variable and the things that are available to you, you're going to be using variables in other programming languages as well. So really, the things that you have done with this simple little stage and getting different things to happen is setting you up and getting you ready to go into a programming language. Or you can just stick with Scratch for a while, do some more programming. The other thing that I want to show you that we hadn't mentioned before, we did talk about the fact that several of the sprites have scripts available. There's also a whole bunch of examples available on the Scratch website. But in addition to that, there are some projects that are available that you can look at. If you want to open some of the projects, I'm not going to worry about my current project, in the pop-up that comes up, you will see some examples. So if you come over here, there's some games that already exist for you to look at. For instance, here is a guessing game. Let's go ahead and bring that up. The script is already there, so you can tinker with it and see what it does. In this particular case, when you run it, the baby asks what your name is. So you type in your name, and the baby says, "Hello there, Donna." And then he or she wants to know, I guess that's a she, which animal that you want the baby to change into. So I'm going to ask the baby to change into a frog. And he makes some noises and turns into a giraffe. But he says, "Oops, I didn't turn into a frog. I turned into a giraffe." And that's what, if you look at the script, it really always turns into a giraffe. But anyway, the main point here is that there are quite a few projects that are available for you. If you want to go out and look at that example area, then you can do some more tinkering and see what you can do with increasing your skills in the Scratch area. We appreciate your feedback, so please take a minute to click on the paperclip and complete the course evaluation. Thanks for taking this course, and we look forward to having you in upcoming courses.